out yesterday will be able to follow. Okay, so calculate the value of the area of triangle EDF and then also triangle BCF. So we're looking at this one here, as well as this one. Okay, so yesterday we have already agreed upon that these two triangles are similar, and then also using the information of this, we have found that the ratio of DF to FC is 1:3. Right? So therefore, to find out what is the area, or rather the ratio of the area, that will be equals to 1/3 bracket squared. Right? Because the two triangles are similar. So therefore 1/9. Okay, so let me write this down. Okay, so that's your similarity property back then when we're looking at area and volume of similar figures. Okay, any questions? Next, we want to look at triangle EDF versus ADF. Okay, ADF is this triangle here. Okay, it is clear to us that these two triangles certainly do not look similar, right? Neither are we able to prove that they are similar also. Okay, so those who have missed out, these two triangles are similar. We can prove it easily by AA similarity test. We do not need to actually prove it. Okay, but you must be very certain that they are similar. Okay, usually for such cases, we can prove by AA similarity. Okay, so for EDF and ADF, okay, I think it's obvious with the diagram that it is not similar. But even if the diagram is just a rough gauge, right? Okay, we can also see that there is definitely difficulty in trying to use AA similarity to actually prove that these two are similar, or rather there's lack of information. Okay, so what do you think we could do to find out what is the ratio?
AD and DE.
Sorry?
AD and
DE. Why would you want to look at this?
Share the same line.
Okay, they share the same height. Good. So these two triangles, they both share the same height. So if I were to compute out what is the area, that will be half times ED times height over half times AD times height. Okay, so this was also a property that we learned last year about triangles having the same height. Then the ratio of the area will actually be the ratio of the bases. Okay, that will be the height. This, okay, maybe this is not very accurate. Yeah, something like that. So now we know that it is ED over AD. We need to know what is the ratio of these two lengths. Okay, we do not know what's the ratio very clearly from the diagram, and also the past few steps. It is not very obvious for us to find out what is the length of ED, neither is it obvious for us to find the length of AD. Although the length of AD, okay, that will be the modulus, or rather the magnitude of 4B. Okay, so we need to find out what is ED, is it correct? So let me write that down first. AD is the magnitude of 4B. So therefore 4 and then modulus B lah. Now how do we find out what is ED? We will need the magnitude of ED first, right? Okay, so rather we will need the vector of ED first so that we can find out what is the magnitude. How do we find out what is the vector of ED? ED can be found with?
Triangle. Yeah.
Sorry, you're saying? Similar triangles. Okay. Is there any other easier ways that we have used in part A already? Have we used any information for part A to find out the vector of ED? Sorry? DF and EF. So ED will be equals to EF plus FD, right? Okay. Which both vectors we have already found in part 4 and part 2. therefore, using that information in part A, we would be able to find that the vector of ED is negative 4 over 3b. Okay? And therefore, the magnitude of ED itself, okay, so this is the length. You can either write this or you can write this. Okay? They both mean the same. So if I were to keep to this, that will refer to this. And we have earlier agreed that modulus of negative 4 over 3 is 4 over 3. So ED will have the magnitude 4 over 3 and then modulus vector 2. So therefore the area so the ratio of the areas will be equals to 4 over 3 modulus of B over 4 modulus of B. So therefore it is 1 over 3. This cancels out. Yes, Noel? Why can't we use the ratio of ED to DA? Isn't that what we use? Why did I, sorry? This part, is it? Why? What do you say?
Can I just use 1 third times 4 because ED and EB are symmetrical.
Okay, so that ED will be EF was actually 1 third, huh? 1 quarter, right? 1 third. This is 1, this is 4 units. So, 1 third. Okay, 1 third of can AD is fine, yeah, can. So let me just write that out. Alternatively, to find out what is ED, we can find that ED is 1 third of negative DA, right? DA is 4. Okay, so you can also use the ratio. This is because triangle EDF. Let me erase B part 1. Because triangle EDF is similar to triangle EAB. EDF, EAB. Okay, any questions? No, shall we move on? For question, example 20, right, I'd like you to make a amendment. I did a typo over here. It should be 3Q, okay, rather than 9Q. Okay. So the question says that OP is given to be 9P. So let me just express it here. And then after that, OQ is given to be 3Q. Okay. And then after it says that OR is 1 third of OP. So this means that this has a ratio 1 is to 2. Because OP is the entire thing, it's 3 units. OR is 1 unit. So to PR, relative to PR, it is 2 units. Okay. Then after that, OS is equals to half of OQ. So therefore, this is just a 1 is to 1 ratio. Okay. Part 1, we want to find out what's the vector of PQ. and as well as the vector of Rs. Okay, could you very quickly find out what are these two vectors? Magnitude of PR.
So you don't know it's a scalar module.
I haven't finished yet. Yeah. Okay, so PR is actually 2 times of magnitude of AB, right? Because of this. So that will be 2 times of magnitude of AB. So therefore, PR and 2AB, PR is equals to 2AB. Let me just trace everything. So therefore, since PR equals to 2AB, then PR is parallel to AB, and PR equals to 2 times of AB. Yeah, the length one there is here, ma'am. So because of this, it resulted in this. So therefore, I will be able to prove this also. Any questions? ABCD is a parallelogram. Okay, which if you recall whatever you have learned in Sec 2 about quadrilaterals and polygons, you might be able to remember what is the property, what are the various properties of parallelogram. But then never mind, if you don't recall, we will look into it in chapter 10 Emaths. Okay, so let me just tell you how we should go about proving parallelogram. There are many ways. So one of the way, okay, is to prove that there is one pair of parallel lines as well as that they are equal in length. Okay, so in order to prove parallelogram, one pair parallel lines, or rather one pair of parallel and equal sides. Okay, so you must be able to draw the conclusion that they are parallel as well as equal in length. You can then be able to justify that that quadrilateral will surely be a parallelogram to AB. Okay. So since we already know that AB is actually parallel to PR, and then also there is a relation of this in terms of the length, okay, why not we just look at CD, okay, to see whether it could actually be parallel to AB or not, right? If this were to be parallel to this, and also if this is parallel to this, surely these two will have to be parallel to each other, right or not? There is time relation. Okay, so we will try to actually prove that these two are parallel by looking at whether CD is parallel to PR. Okay, so surely we will not be able to use C with reference to Q and D reference to Q because there is no line segment connecting them. Right, so we will look at then changing our reference point to look at S instead. Okay, so let us define another set. So let SC to be equals to C and SD to be equals to D. So it's the same procedure. So SR will be equals to 2C and SP equals to 2D. I'll just skip through writing down what are the two vectors that we're trying to add. Okay. If you are fast enough, you should be able to catch already by now. Hopefully. If you are not fast enough, it's okay. So this is actually negative of SC plus SD, and then this is negative of SR plus SP. Okay. RP can be expressed as 2 times of CD. So we can draw the same conclusion. So RP, if it's equals to 2 CD, okay, RP and CD are parallel. So therefore, CD is parallel to AB. So we have proven one pair of parallel lines. Now we need to go into proving that they are going to be equal in length. Okay, so looking at the magnitude, so we have RP equals to 2 CD. So 2 times of AB equals to 2 times of CD based on what you have found in part 1. So AB is equals to CD. Okay. Therefore, no, direction doesn't matter in length. Okay, that's why I changed into length notation. So the direction doesn't matter. Otherwise, it should have been BA to CD. Okay, because in length, it's a scalar form. So since AB is parallel to CD and AB equals to CD, then ABCD is a parallelogram. Any questions? Questions, homework question 8, 10, 13, 14 and 18. We got Friday also. Friday Yap says no. So Monday. Okay, I think since so many of the people are not here today and I see that Amelia is preparing to go off, right? You're going off already, right? Not yet?
Off by 11, but then it's okay.
What do you mean it's okay? You're forcing Mr. Lee to go into a mad rush, you know?
No, it's not our lunch.
Oh, okay. I don't need Mr. Lee come and tell me I'm holding you hostage, huh?
Okay.
Anyway, okay, I think let's just do the homework in class. Okay, you can do your exercise 5D now, right? For the remaining 20 minutes.